Thanks, Sean. Yeah, so I'm going to be talking about accelerating electrification of California's multifamily buildings, lessons learned. My name is Jack. I'm from the Association for Energy Affordability. Next slide, please, Elijah. Just like Sean mentioned, the Association for Energy Affordability, we implement a lot of incentive programs. Now, what I'll be presenting on are just not lessons learned just from the LIWP program, but also all of our various programs that we implement. I'm a technical leader from our organization, and I help design our programs and ensure that all the projects that we're doing are successful electrification projects. And so, beyond the programs that we implement, we also provide technical services. Sort of intertwined with our programs are our technical services. All of our programs have a technical sort of support aspect to it, and that's a lot of the work that I do, is helping people actually do these electrification projects successfully. Next slide, please. So today, I'm going to talk about some of the lessons learned of implementing electrification retrofits in affordable housing for the last 4 or 5 years. Back in 2021, I helped author this report called Accelerating Electrification of California's Multifamily Buildings, really sort of like a technical guide on how to electrify affordable housing and multifamily buildings. The irony is I probably completed maybe 15 projects at the time that I wrote this. Still, a ton of really great information. Redwood Energy also came out with a pocket guide to all electric retrofits of commercial buildings around the same time, just a year later. These are 2 great resources that I still use today. Anyone that comes to AEA, I provide them with these resources and have them review them. But after sort of implementing the strategies that are in these reports at scale over the last 4 years, we've learned a lot. And so today I'm just going to try and run through some of the big ticket items that I've learned that if we're going to continue to accelerate electrification of our multifamily buildings, specifically in affordable housing, these are some of the things that we need to change and sort of think about as we approach electrification. Next slide, please. So, like I said, lessons learned. I'll cover all of these. It's going to be quick because there's a lot to cover, so I'll go as fast as I can to leave some time for Q&A. Next slide. Next slide. Alrighty, so one of the biggest lessons learned that I've had from HVAC is noise. What we find is that it's a fairly, there are different form factors of HVAC that fit in different spaces, but some of the biggest feedback we've had from residents is noise. And really, this guy here, the package terminal heat pump. Almost every project that I've installed a package terminal heat pump that looks like this, or your standard 240 volt package terminal heat pump, we get complaints about noise. Even if there's an existing PTAC there that we're just like for like swapping out, because it's providing heating, it's going to be running more often, and residents don't like the noise that these make. If you look at like a mini split indoor unit, 19 to 30 decibels, we get no complaints around noise with these units. And really, we have got really great feedback from residents for putting in mini splits. I mean, obviously mini splits have higher efficiencies, but just like comfort, tenant satisfaction, the mini splits are just far beyond like the package terminal heat pump. And then in between, we have the Apoca unit and the Gradient that have, sort of moderately loud, or compared to the package terminal heat pump, they're a little bit less noisy. But I will say, one thing that's really unique about noise as well is that they have these decibel charts, right? I spend so many times in trainings, 60 decibels, moderate to quiet, it's just like a conversation. But in reality, there's a whole other sort of spectrum of quality of noise that we don't really think about. And sound of 2 pieces of metal rubbing together at 40 decibels sounds a lot different than someone talking at 40 decibels. And it has a really big impact on, how the quality of life for the people that live here. And so these are considerations that we need to make in order to successfully retrofit these projects. Next slide, please. In addition to the interior unit, the exterior unit noise has also been a big issue. This is a project that we just finished recently, about maybe 2 weeks ago. It's a 16-unit building where we did central heat pump water heating with Sankos, as well as mini split units. I think they were Daikin, but anyway, you see this window here? That's a residential unit's window. I think it's their living room. But we have a Sanko compressor, Sanko compressor, Sanko compressor, Sanko compressor, and then also the compressor for the mini split, all sort of around this window. Now, a few years ago, we would have just left the window the same, and we probably would have gotten a call from the building management that the tenant is complaining about noise. But as part of the project, we also want to support weatherization. Of course, electrification plus weatherization is key. We added wall insulation, replaced the windows, and it's totally quiet in the unit. So these are the types of things that we may not have thought about earlier in our process, but we're starting to implement now and having a lot more success, and people are happier about it. Next slide, please. One of the biggest challenges that I've found in electrifying existing multifamily buildings, especially affordable housing, is our historic buildings. These are buildings that are located in downtown San Francisco, downtown Vallejo, all throughout California. And a lot of these systems, a lot of the existing types of HVAC are hydronic and steam. So our retrofit options for an existing hydronic system is to go to a heat pump chiller, which we've done a few projects with carbon zero buildings that have been very successful. There are some considerations. A heat pump chiller is going to work in every building that has an existing hydronic. If you have steam, really your only option is a VRF. And VRFs are really expensive. So sort of widely what has become the most feasible solution for these older buildings are these 120 volt room heat pumps or package terminal heat pumps. But the biggest blocker that we've had in installing these across all of these historic buildings is the planning department in these different cities. And can anyone tell me why? So this building was done in Vallejo a few years ago. And then this is a NYCHA project where they installed gradient. And the City of San Francisco allows us, which is great, to call the planning department and ask, will this work, without charging us. Other cities are not nearly as nice. San Jose always charges us. It's not very nice. But can anyone tell me why the City of San Francisco would approve this over this in terms of a planning department and alterations to the facade to make sure the building still looks the same as it did in 1920? Permanent versus removable, exactly. These are things that I didn't think about. I've tried to install APOCAs in countless buildings in San Francisco that are brick and old, and I've only had success on 2 because there's existing vents. But yeah, exactly right. I wouldn't have thought of that. And so in order to scale electrification of these affordable housing buildings that are historic, we need better communication from the planning department to understand what can we actually install. Next slide, please.
Can you go over the first picture? I
Yeah.
still don't understand what is it that we installed.
Oh yeah, so these are the APOCA units, so that's the ducting right there.
Oh, I see.
So, that's like really small alterations to the facade, and they wouldn't allow it, but then you put this big clunky thing there and it's approved, so.
Condensate lines were added too?
Yeah, you can see the condensate there. The gradient doesn't actually have any condensate lines. They just spray the condensate, which in New York, it'll be interesting to see if it turns into snow and they spray it out. They don't know. I asked them and they're not sure. So we'll see. Moving on to DHW, next slide. So in order to install more central heat pump water heaters, we need more equipment. Incentive programs love CO2 heat pump water heaters. I mean, we should all love CO2 heat pump water heaters. They are more efficient. They use CO2 that has a global warming potential of 1. But there is a huge gap in the market for California where you have a 15.2 kBTU-H Sanco unit, and then the next size up is a 138 kBTU-H Mitsubishi, which ends up with installs like these, where you just have a wall of heat pumps. And if we had much more variety of capacities between 2 to 6 tons, I think we would see a lot more adoption. Building owners see this and they think about how am I going to maintain it, headaches, et cetera. But ultimately right now, this is the only option that we have to install. And so if we had more variety of capacities, that would be a huge help to get more people to install central heat pump water heaters. In addition to the heat pump water heater itself, we also need variable or smaller electrical elements in swing tanks, as well as residential heat pump water heaters, commercial integrated tank heat pump water heaters. More options for element sizes is going to be critical. I mean, Sanco, the only element that they sell in their swing tank is a 12 kilowatt element. We don't need a 12 kilowatt element in our swing tank for an 8-unit building. That's going to drive demand charges up. So being able to swap out elements to put in 4 kW, 2 kW. Also, you have these residential electric resistance tank type water heaters that you can use for swing tanks, but the ports on them are tiny, 3/4 inch. we finished a project where the swing tank has a 3/4 inch port, and it's for a 101 unit building. All of the flow of 101 units has to go through a 3/4 inch port. And so smaller elements, larger ports, and we'll see more projects get done. Next slide, please. This is something that is really dear to my heart, and some of the things that I work on most of my time at AEA is talking about recirculation loads. So one of the reasons why a centrally pumped water heater fails, and trust me, I know because I've worked on them that have failed, is because we're sizing them incorrectly. And we're not sizing them incorrectly because we don't know what we're doing. Well, we might not know everything, but we don't know what the recirc loads are. In every central domestic hot water system, you have a hot water line going out, hot water coming back. More complex, you might have multiple loops going back and going out and coming back. This right here, this graph on the left, is the percentage of load that is recirculation or distribution losses in domestic hot water buildings. Sample size is 21. Blue is low income, seniors, green is low income, and this like teal color is market rate. We don't have that much market rate data because we mostly do affordable housing, but you can see the low income seniors. We have projects where 92% of the load is reheating water coming back to the distribution system. How do you size a heat pump water heater for that, where you have a swing tank that is in charge of reheating that load? It's almost impossible. You're going to have electric resistance water heating. And then in addition, sorry, Sean, but this is like the Ecotope 100 watts per apartment. Like if you compare that to the watts per apartment that we're seeing in our buildings, it's all over the map. I mean, and so this is why centrally pumped water heater systems fail, is because we're not taking the time to actually monitor the distribution system and improve the distribution system. We've seen really, really high savings by improving imbalance, removing crossover. We've oversized all of our piping, which has increased heat loss. So these are all things that are critical to consider when you're installing a centrally pumped water heater to avoid failure. And one black eye of a centrally pumped water heater is like 10 steps back for affordable housing developer. And so we really want to avoid that. Next slide, please. In terms of residential heat pump water heaters, ultimately, we need better insulation and ventilation direction from manufacturers. It's all over the place. As I implement incentive programs, I will see a residential heat pump water heater get put into a small closet without any ventilation, and I'll have the contractor call the manufacturer and say, hey, is this approved? And they'll say, well, it'll provide hot water. So we need better ventilation direction from manufacturers. This is really interesting. 120 volt heat pump water heaters being installed in exterior closets, Rheem versus A.O. Smith. When I call Rheem and tell them that their 120 volt heat pump water heaters that are shared circuit or dedicated circuit are being installed in exterior closets, they go, ooh, that's not a good idea. No literature ever anywhere that they say that you should not install these in exterior closets. Actually, some of the literature seems like they're recommending exterior closets. Whereas the A.O. Smith 120 volt shared circuit, it has electric resistance backup. And so it can be installed in exterior closets. But there's no literature that says that it has that 900 watt electric resistance backup. So if we're going to install these properly in buildings, we need better information from the manufacturer so that we don't screw it up and we don't have people running out of hot water on the coldest day of the year. Condensate pump interlocking and wiring condensate pump on the same circuit as the water heater. This is a project that Andy and I are working on where we needed a condensate pump. Rheem doesn't have a way to interlock the condensate pump with their heat pump, which is required by code. So you're providing equipment that we can't meet code with. And so it's just making it harder and harder to install this equipment. Also, condensate pumps draw like maybe a tiny amount of wattage. Why can't we just power it from the heat pump? That reduces the amount of circuitry we need, reduces cost. And then we need more split heat pump water heating options. Sanco is way too expensive for a in-unit heat pump water heating system. And we have this ecological coming out, but we go into a building and there's a 30-gallon gas water heater in a tiny closet where it's 21 inches by 21 inches, and no heat pump water heater on the market right now can actually fit in that closet. So we chalk it up that we might do it in the future once there's a product available. Next slide, please. Alrighty, induction cooking. After Sazi's presentation, I was really happy to see knobs. That's one of the biggest things that we get feedback from manufacturers, building owners. The other thing that I didn't include here but made me think during Sazi's presentation is we also get a lot of complaints if we install induction without a backsplash. Things fall behind it. It adds, you have to clean the wall when people move out. We've done a few projects with copper channing stoves. One of the biggest sort of issues or unforeseen issues that we've had with these products is the need for Wi-Fi. And I think just in general for multifamily, especially in affordable housing, if your product needs Wi-Fi, it's going to add a substantial amount of cost and be a huge headache for the building owner. The projects that we've completed where we've installed copper channing stoves, we're looking at $1,000 plus per unit to add Wi-Fi just to push updates and just to track the usage of the system. So, I like simplicity. It goes a long way. Countertop induction burners and countertop ovens help with load calcs, but alterations to counters are costly. So if you're able to split into a small oven and a countertop cooktop, it's great from the NEC load calcs perspective, but actually implementing that retrofit can be difficult. I can't emphasize this enough, but consider offering a pot and pan set to residents when you purchase your stoves for your property. They're going to be really excited about their new pots and pans, and they're not going to care too much that you've just replaced all of their appliances. Next slide, please. Electrical infrastructure. So I only have 5 minutes left, so I'm not going to bore you all with this confusing code language. Oh, 10 minutes. Oh, perfect. Cool. Still not going to bore you with all this confusing code. But if you go to the next slide, these are all ways. Oh, one back, sorry. Thank you. These are all ways to calculate existing load in your multifamily buildings. The yellow highlighted one is the one that we use the most and what we found to be the most effective, which is actually using real utility data or monitoring data to determine, yeah, right?
Crazy.
Exactly, yeah. There's way more capacity out there than we think. We can electrify so many projects just by taking the extra step to monitor the existing load rather than calculate it. Next slide, please. And just to illustrate that, here is some data from Home Energy Analytics that shows that they have 22,000 homes in California. These are the peak amp draws for those homes, and the majority of them are well below 50 amps. And so do we really need 200 amp panels? Not necessarily, especially in multifamily. Next slide, please. And just to compare, right, this is a research project that we worked on in Palo Alto where we installed mini splits in every unit. Each building was about 25 to 30 units. But this first column here is the deemed calculation. So this is what, if you plug it in to the electrical load calculator or National Electrical Code, you follow the code, you add up all the appliances, you add diversity factors, it tells us that we need 243 amps for building A, 315 amps for building B, and then we monitored. We could do whatever we wanted. In terms of, we could add all sorts of electrical appliances with that amount of capacity available. Post retrofit, we monitored it again. So, and we also compared to the electrical load calc. So you see, increase, you see the increase between pre-retrofit and post-retrofit, but look at the amp reading increase. It's tiny.
How many units is this building?
I think building A was 25 units.
Wow, and they're only using 44 amps?
Yeah, that's their peak draw.
Per unit?
For their whole unit, for their whole building.
Wow.
For the whole building.
22 units, exact. How?
Yeah. People are there at different times of the day. People aren't using appliances at the same time. You think about it for a single family home, right? You have, the diversity factor is dependent on like a single family, right? Where this is, 25 families, all with different schedules, and just as you increase that number, the diversity increases, and our peak load draws decrease. That is, that's not per unit. That is the whole service.
What?
Yeah.
Then what is building B? How many units?
It's the same building type, 25 each.
25?
Yeah.
Whoa.
Yeah. And this one saw a slight increase, so 16 amp increase compared to the other one. Yeah. And so, oh, go ahead.
It would seem like when you convert to electric cooking, that would everybody kind of cooks at the same time.
Yeah, this just did HVAC and just did mini splits. So,
I see. So
yeah.
HVAC is the only major, no EV charging or no nothing.
No, yeah, just HVAC.
see.
But we are now doing projects where we are phasing them in a way that we just monitor in between each phase. Do the HVAC, monitor, and then we do cooking at the end. It's kind of like our process. So we do HVAC, DHW, and then you monitor, and then you put in the stoves. That's
This is HVAC and hot water?
just HVAC for this, yeah.
But it's three-phase,
Yep, it's three-phase.
240? Or?
Yep, 208, three-phase 208, yeah. Yep.
Do you have like a probability distribution of the, like a histogram or something that doesn't just show peak, but like what's the 99, 30, 30?
I don't, but we should. We can do that, yeah, with this
It
data.
might be interesting to have it weather normalized too.
Yeah,
Like,
Yeah.
what's the peak on that? Because we often see huge differences. Your average peak is going to look very different than the two 90-degree days.
yeah, yeah.
So having a weather normalized peak reading is
Mhm.
going to be helpful when you're looking at HVAC, cooling and heating loads, because it's skewed toward
Totally.
the coldest and hottest days.
Yeah, and this is, for these amp readings, we're actually following what's required by the electrical code. We're doing a 30-day load study during the peak, during the month where you're going to see the peak HVAC usage.
So your actual amp readings are for the peak months?
Yeah,
I see.
yep. Yeah. Any other questions on this?
Did you think about the demographics of people who are living in buildings?
They're the same. They're all, well, I should also add, low-income seniors. So seniors also are going to use less.
I have a question from a bit ago. Is that fine?
Yeah, of course.
The Wi-Fi $1,000 per unit cost, was that the cost for installing Wi-Fi where it wasn't there, or is that the cost for configuring Wi-Fi and connecting it
Yeah.
and commissioning the system to be on Wi-Fi?
Good question. Installing it where it wasn't there. I mean, multifamily buildings aren't going to have like a central Wi-Fi that we can connect all of these appliances to. So you have to add it in order to like push updates to the appliance or control all of the appliances together.
And then did they charge a subscription too on top of that?
Yeah. So that does not include the subscription. That is just the quote to put the Wi-Fi in.
Yeah.
We actually asked a couple the other day, does it need Wi-Fi? And they said, nah.
Yeah, but if affordable housing, right? Like you're either going to spend money on Wi-Fi or you're going to spend money on your maintenance trying to figure out why the thing won't work, right? And so they find that it's more cost effective to just pay for the Wi-Fi so that you can track all of it. And then also part of it is, when are we going to load up and charge these different devices? When or these stoves? Like, are we going to have everybody on the same charge cycle, or are we going to need to split it up? And that's something that we're not sure about. And so that we need the Wi-Fi so that we have that data so that we can charge it up at different times and so that we don't trip the service. Because if you ever installed a copper channing stove in a multifamily building and have done the load calcs, you just can ignore the stove and call it as a part of the small appliance circuit, which is great, but then in reality, like, what does that actually mean in terms of, tripping the stove or tripping the service? Next slide, please. So this section is on smart panels, smart breakers, circuit splitters, and meter socket adapters in multifamily. Mostly questions. I have tried to push these on multifamily buildings for several years now, and I have had one project successfully install it, and that was these simple switch here. And some of the barriers that we see is, like, if we're triaging load, what loads can we triage in a multifamily dwelling unit? I mean, you have cooking, you have HVAC, and you have water heating. Those are all critical loads that you're required to provide. And so as a housing owner, you don't want to switch off the cooking. Like how does that impact your rental agreement, you know? And so those are some of the considerations there for multifamily.
What about refrigeration and water heat, which if they can maintain their load for a while?
Yeah. Typically, refrigerators are going to be on your small appliance circuit, so you don't have a dedicated circuit for those. And then water heating, we have seen success with. Yeah, I mean, water heating, we have 120 volt. That's like much more cost effective than connecting a smart splitter to it. And then I've asked utilities this, and I haven't gotten a straightforward answer, but if every unit had a smart panel and was load triaging at 60 amps, and we're always like around like between 30 and 50 amps, are we still going to trigger a transformer upgrade? And how do they determine that? And how do we calculate that? And how do we make sure that we avoid that? If 100 units are all reaching their peak amperage consistently, it's a totally different equation of how utilities have been sizing transformers for years. What loads can we connect to a meter socket adapter? I mean, I think someone alluded to this earlier, but like multifamily, we have these big meter banks, and like they are often located in areas where there are no loads anywhere near them. So what can you connect to those? I mean, the CPUC asked us to look into it and look into the feasibility, and we're not sure. So the wide application of those in multifamily, I'm a bit skeptical, but I'd love to hear others. And then safety considerations, right? This is not a single family home. These people do not make the decision to add a smart splitter or smart breaker into their home. And so you need to be really thoughtful to make sure that it's intrinsically safe. We added like a anti-tampering device, but if I was a if I was in a dwelling unit and every time my HVAC kicked off, my stove would turn off, I would probably try and hack this thing. Next slide, please.
So regarding the meter socket adapter,
Yeah.
Do you see EVs, the common EV charging being used with this technology?
Yeah, not necessarily with meter socket adapters. I think load management, like EV load management on the common area meter, is much more effective in multifamily. Like you could have 15, 20 EV chargers all connected on a small electrical power or small capacity circuit. And if one person's charging, they get all the power, and then otherwise it's split across. That seems like a much more applicable for multifamily. Resident education, I know I'm running a little bit on time, so I can't tell you how important resident education is. What we found to be really, really successful is hosting education resident meetings and trainings on how to utilize their new HVAC, their new water heating, their new stoves, host cooking demonstrations, and then provide pot and pan sets for new tenants when retrofitting properties with induction cooking. People just want to be in the know. I mean, they're going to have a general frustration with you if you don't let them know that you're retrofitting their appliances. And just as simple as letting them know, hey, like we're going to do this, they seem to be a lot more appreciative of the change. For all electric buildings, some of the things that I see people do is with HVAC, they are uneducated about how their HVAC works, their new heat pump. And I walk into their apartment and I ask them if they use their heat pump, and they say no because it runs too long. And they think it ran for 30 minutes, it's running too long, I'm going to shut it off. It's not like their wall furnace anymore. Ensure you are selecting an easy to use thermostat. Mini split thermostats are terrible. They get lost. I don't understand why you can't just like mount it on the wall and have like a hot, cold, and then a simple schedule. That'd be a huge help for the projects that we work on. And then a lot of our projects are also putting in solar PV systems, V&M, so provide support on how to read a utility bill. It's confusing. It's confusing for me, and so having someone on site that knows how to read it to help support the residents there is critical. Next slide, please.
But your solar generation doesn't come on your utility bills.
In like a virtual net energy metering, it will like sometimes show it.
Okay.
Yeah.
You can't see how much the building is using from solar on a bill. You can only see what's being sent back to the utility. It's different.
Exactly.
Yeah.
And I wonder, like there's solar, then there's also battery storage. It all gets pretty complicated pretty quickly.
Yeah, self-consumption is invisible to the utility.
Yeah.
Exactly.
Yeah, so reading utility bills is important and being able to read them.
Oh, I was just gonna say, on the few projects that we had worked at, all of them had the tenant education seminars both before installation and after, as well as a lobby monitoring that looks at a whole campus meter and shows exactly that peak versus what's being exported,
Cool.
et cetera.
Oh, yeah, that makes a lot of sense. We do the pre and post, but we don't have like the monitoring.
Ongoing real-time monitoring.
Yeah,
I think it's interesting, and the tenants seem to be really, that we show them how to read the ISO today from the California ISO.
Yeah.
Like, hey, and so they kind of like it. It's like gambling.
yeah, totally. Yeah, absolutely.
I'm gonna get, or day trading.
Yeah.
So yeah.
Absolutely, yeah. No, great point. And then this is just cost data. As an incentive implementer, when I look at this, I think about how most of our programs are flat rate incentives, and you have these large standard deviations of cost throughout, and we're leaving behind the hard to install or the more costly projects because we want to provide a flat rate incentive. Additionally, some of our programs are, bigger. Our biggest program, LIWP, is based off of energy savings. So the incentive scales based off how much carbon you're going to reduce and how much energy you're going to save at the site. So that is why water heating, central heat pump water. Yeah, so yeah, and that is because the common area really means central electrical upgrades, so like service upgrades, panel upgrades. So the scale of what that can look like is substantial, and unfortunately we don't track like this common area panel went from 100 amps to 200 amps. That's just under the common area electrification measure. But if some properties underwent a full service upgrade and then had to upgrade their transformer, so that's why we have a huge standard deviation there. And to the point I was making earlier, if we're going to hold everybody at like a flat rate incentive, I mean, one of our programs provides $5,000 for common area electrical upgrades, whether it's a panel, whether it's a service upgrade. It's not sustainable, and we're not going to scale if we're only providing that small amount of incentive. But in some projects, it fully covers the cost, but we need to be able to scale and, be more critical about our own flat rate incentive structure. And if we're going to do this in every multifamily affordable housing building in California. Perfect. That's it, I think.